Hey everyone, welcome back to The Explainer. We're diving straight into Google I/O 2026 today, and specifically this massive post-prompt agent revolution. We're talking about a tectonic shift in the tech landscape right now. If you thought AI was just about, typing a prompt into a text box and getting a generic essay back, you're going to want to pay close attention to this. So, are chatbots already obsolete? I know, it sounds a bit crazy to even ask, right? But according to Google's latest roadmap, the answer is a resounding yes. Raw text completion, passive prompt engineering, that era is structurally over. What we're stepping into is an entirely new autonomous reality. The AI doesn't just talk to you anymore, it actually goes out and does things for you. Okay, let's dive into this new post-prompt vocabulary. We're officially entering the era of what they call systems of action. Basically, AI is graduating. It's moving from being a passive assistant that just sits there waiting for your command to an active supervisor. We're talking about systems capable of planning, executing, verifying, and governing complex multi-step tasks, all on their own across distributed networks. And fueling this is a brand new foundational fleet: Gemini 3.1 Pro for that deep multi-step reasoning, Gemini 3.5 Flash for high-frequency tool calling, and Gemini Omni, this unified architecture that handles text, image, and video totally natively. To really get a feel for this, let's compare the two paradigms side by side. Think about legacy AI. That's what we've all been doing. It relies heavily on passive text completion. You ask a question, you get an answer. Simple. But the Google 2026 approach, that is all about stateful, autonomous execution. We're transitioning to this deeply integrated, active ecosystem where the AI actually retains memory, manages its own task lists, and operates completely independently over long periods of time. All right, part one, the enterprise stack, from Vertex AI to Gemini agents. So the crucial point is how Google is structuring this massive shift to help businesses actually use this stuff. How do you go from a couple of simple experiments to securely managing thousands of parallel workloads? Well, they've anchored it with four central pillars. First up is Build, using Agent Studio and the new Agent Development Kit version 1.0. Second is Scale, which allows these massive multi-day tasks to run on an asynchronous agent runtime. Third is Govern, and this is huge for security, keeping things strictly locked down with verifiable SPIFFE IDs and filtering out prompt injections using model armor. And finally, Optimize, giving you automated pre-deployment validation using LLM as a judge scoring. Now, what's genuinely interesting here is how Google is making this enterprise-grade infrastructure practically achievable today. They aren't just crossing their fingers and expecting companies to build all this security from scratch. No way. They're accelerating adoption through native, zero-trust integrations with some serious heavy hitters. They've partnered up with enterprise security titan Wiz for multi-cloud runtime protection and Promavio to bring this governed automation directly into Google Workspace environments. It's a real game changer. Moving down the stack to Section 2, the developer revolution, standardizing the agent lifecycle. So, what does this actually mean for the folks writing the software? For technical teams, Google is rolling out the agent development lifecycle, standardizing the whole shebang with a brand new Agents CLI. It breaks down like this. Step 1, Agents-CLI create, scaffolds your base directories, and sets up the guardrails. Step 2, Agents-CLI Playground gives engineers a local web environment. You can literally inspect real-time tool calls and follow the AI's reasoning paths as it works. And step 3, Agents-CLI Deploy packages up the code base and pushes it straight to a serverless runtime. And get this, the runtime is absurdly efficient. We're talking sub-second cold starts. That means these agents can scale instantly from 0 to thousands of active reasoning loops in the blink of an eye. Which brings us to Section 3, Google Antigravity, the agent-first IDE. This is arguably the most disruptive developer tool they revealed. Visualizing this split-screen paradigm is absolutely key. On one hand, you have the editor view. We all know legacy coding assistants. They give you inline commands, tab completions. That's your editor view, powered by models like Gemini 3.1 Pro and Claude 4.6. But then, on the other side, is the manager surface. It functions as an asynchronous mission control dashboard. Just imagine this. You're writing code in one panel, while simultaneously dispatching 5 autonomous agents to hunt down and fix different repository bugs in the other panel. Software engineering just literally became a collaborative workflow with your AI. Of course, the elephant in the room is transparency. How do you actually know what those 5 agents are doing behind your back? Enter the artifact system. Instead of forcing you to parse through raw, confusing terminal logs, developers get structured, human-readable deliverables. This includes code diff summaries and, this is wild, actual recorded headless browser video clips proving that a front-end bug fix works. It bridges the transparency gap beautifully. You can leave dynamic feedback directly on the artifact, and the agent just alters its plan on the fly without having to restart the whole task. Okay, Section 4, Consumer Autonomy. Android 17 and Gemini Intelligence. Let's shift gears away from the developer backend for a minute and talk about the real-world consumer experience. Grounding this abstract idea of multimodal screen reading is so important. So picture this. You're in your Notes app on a brand new Android 17 device. You long press a super messy, totally unformatted grocery list. Instead of just highlighting the text like the old days, Gemini autonomously reads your screen, opens up a third-party delivery app, maps your weirdly named items to actual local store inventories, and preps the entire checkout transaction for you. Boom, no manual user intervention required. In this fast level of autonomy, it's supported by an equally massive consumer ecosystem. The whole thing is anchored by the Universal Commerce Protocol, which brings in secure integrations with Meta, Microsoft, Stripe, and Klarna. And on the desktop side, Google introduced Aluminum OS for a new premium hardware category called Google Books. This OS features the DeepMind Magic Pointer. Basically, you just hover your cursor over some unformatted text, like a static email thread, and it instantly extracts calendar events contextually. It's like magic. All right, Section 5, the Compute Foundation, powering the agents with TPU v8. But wait, how on earth do you run millions of these complex, multi-step agent workflows globally without the server costs completely spiraling out of control? Well, it all comes down to the physical silicon. 121 exaflops. Honestly, my mind is just blown by that number. To handle these massive global compute demands, Google engineered the TPU-8. It's built specifically for high-density agent training and trajectory optimization. They're packing up to 9,600 of these custom chips into a single superpod to deliver that staggering 121 exaflops of training compute. But here's the clever part. There's a specialized split in this custom silicon. While the TPU-8T handles all that heavy, high-density training, the TPU-8i is hyper-optimized for multi-agent inference. Why the split? Well, live agent reasoning loops require constant tool execution and validation steps. Fast inference is literally the ultimate bottleneck here. If the AI takes too long to think, the whole autonomous illusion just breaks down. The TPU-8i is designed strictly to eliminate that latency. And they achieve that insanely low latency with some truly massive hardware specs. Get a load of this metric: 19.2 terabytes per second of interconnect bandwidth. On top of that, they tripled the on-chip static RAM to 384 megabytes. What does all that math mean? It drives an 80% improvement in performance per dollar and a 5-fold reduction in latency. They've essentially made live, massive production workloads economically viable. Finally, Section 6, Strategic Outlook, the vertically integrated future. Let's zoom out for a second and summarize everything we've covered today, because it brilliantly illustrates the sheer scale of the new architectural paradigm we're entering. There's this great quote from the source: "Software transitions from a tool you command to an agent that executes on your behalf." And that hits the nail on the head. By vertically integrating absolutely everything, from the custom TPU v8 silicon up to the Gemini Enterprise Agent Platform, the Antigravity IDE, right through to Android 17, Google has built a completely unified stack. They are designing a future where autonomous agents are the fundamental substrate of computing itself. Which leads us to the final and really the most important question of this explainer. As software transitions into an autonomous agent that executes on your behalf, what will you build next? We are officially moving past the days of simple text completion and charging straight into an era of autonomous action. I really hope this structured look at the post-prompt era has given you a clear, exciting understanding of the tools and systems heading our way. Thank you so much for hanging out with me to explore this fascinating shift, and as always, keep learning.